Hello and welcome back to the course on computer vision. Today we're going to find out how GANs work. So this is going to be an interesting tutorial, some exciting slides prepared ahead. It's going to be quite long, so prepare yourself for that. And let's dive straight into it. Alright, so as we discussed, GANs stand for Generative Adversarial Networks. And we're going to go through these letters one by one, and then we'll get to the training part of the GANs, which is the exciting part. Alright, so G stands for generative, and this is a model which takes as an input a random noise signal, and then it can output an image. The adversarial part stands for the discriminator. It's another model which is going to be rivaling the generator, is going to be the opponent of the generator. You can think of the generator as like a thief or somebody who's trying to forge dollar bills, and the discriminator as the police officer, as the detective. Oh, D, there you go, D for detective. So D is going to be the rival of the generator, and D is a model which is capable of learning about objects, animals, or people, or basically certain features, capable of learning features. For instance, if you show it lots of dogs, and then you show it lots of non-dogs, it will be able to, after that, discriminate between dogs and non-dogs. So in an ideal world, if you show the discriminator this image, it'll say 0. It'll give it a 0 probability that it's a dog. And if you show it this image, it'll give it a 1. It'll give it a 100% probability that it's a dog. So that is the ideal world. Now we're going to get, now we have the letter N. So that's why we had this little animation. You'll see, there we go, the network letters jumping around. And that stands for the fact that these two models are actually neural networks. So we're going to replace them with neural networks because that's what they are. So we got a neural network on the left, a neural network on the right. And why that's important is because as we discussed in the annex to the course about neural networks, hopefully you checked that out, they are capable of learning. That's where, the weights of those synapses that we see in blue, that's where information, that's where the training is going to go. That's where those weights are going to be updated so that the neural networks learn. Alright, so we discussed the letters. Let's go through the training. Exciting times. Alright, step 1. Basically all the steps, it's not like step 1, step 2, step 3 that you need to consecutively. Not that they're different. We're just going to be repeating the same step. We're going to be doing it many times. In fact, here in this intuition tutorial, we're going to do it 3 times. In the practical tutorials, you're going to do it hundreds and thousands of times. But for intuition, it's going to be enough 3. But basically, you will see how the networks evolve over the iteration. So every step is an iteration. Don't confuse step with epoch, though. An epoch is after you've done your steps, that's one epoch, and then you do another epoch, that's you do all the steps again and again. So you'll see that in the practical. But back here, what we have is step 1. We input the noise signal into, or a noise signal, a random noise signal into our generator. It just basically kind of like gives it some randomness to generate from. It needs to start somewhere. And then it generates some images. These images are, as you can see, completely useless, completely random images. And at this stage, who we want to train is, we want to train the discriminator. So this is what we're going to be doing, and you will see exactly these same steps in the practical tutorials. And this is how the generative adversarial networks concept or algorithm was designed in the first place. So first we train the discriminator. And as we discussed, we want the discriminator to be able to distinguish between, for instance, we're going to stick with the example of dogs, between dogs and non-dogs. So we need to give it, in addition to these random images that we generated, we need to give it some dog images. So there you go. We've got some dog images, and so we're going to input these, a batch of non-dog images and a batch of dog images. We're going to put them into the discriminator, and we'll see what probabilities the discriminator will spit out. And remember, the discriminator knows nothing at this stage, hasn't been trained at all. This is the very first step. None of these two models have been trained. So the discriminator might spit out numbers like this. For instance, 0.8, 0.3, 0.5, like quite high probabilities for the images at the top that they're dogs, even though we can see they're not dogs. Discriminator has never seen a dog before. So it might give them some, just based on its initial configuration, will just give them some probabilities. It doesn't really worry us at this stage. It's got to start somewhere again. But it's got to start somewhere. And we'll fix this as we go along. As it trains, it'll fix this. And then it gives some probabilities to the images below. Even though we know they're dogs, discriminator has never seen a dog before, so it just gives them some probabilities that happen to be the outputs of this neural network at this point in time. Or at this stage, at the very beginning, at the very first stage. So what happens next is we take these values and we look at what they should have been. So we as humans, because we're training this neural network, we know what it should have output in the ideal scenario. In the ideal scenario, the top values should have been zeros, the bottom values should have been ones. So the top values, pictures are not dogs, so they should have gotten a 0% likelihood of being dogs. Bottom ones should have gotten 100% likelihood of being dogs. So that's the ideal world. Obviously, our model isn't ideal, but it can learn from this. So what's going to happen is the error is going to be calculated. So basically, in every single case, the values will be subtracted one from the other. So 0 minus 0.8, 0 minus 0.3, 0 minus 0.5, and 0.1 minus 1, and so on. So all those will be subtracted. Then the cumulative error will be calculated and will be back propagated through the network of the discriminator. So if you're not familiar with the term backpropagation, then I highly recommend checking out the annex of this course, where we talk about artificial neural networks and convolutional neural networks, and you will be after that you'll be up to speed with everything I will be discussing, including backpropagation. It's quite a lengthy concept. We're not going to discuss it here, but if you are aware of backpropagation, then this is exactly what's happening here. These errors are backpropagated through network, and the weights of the network are updated. So there we go. Now the discriminator has learned. That was basically the learning process of the discriminator. It's learned from its mistakes, and next time it's going to do a better job. And now we want to train the generator. So this part of our GAN. And how we're going to train the generator is we're going to take the same images that we've created, this batch of images, which are supposed to be dogs, and we're going to use them again. So a quick note here is that you will notice that this is exactly what we did in the practical tutorials. We took the images that we had generated for the training of the discriminator, and we used those same images. In his paper, Ian Goodfellow recommends generating new images, so running the noise part and the generation part again and using those images for the training of generator. We just use the same images and it worked totally fine. It's up to you how you want to go. You might want to experiment with this part in the practical if you like, or just follow along with our tutorials, and the networks work really well. But just so that you're aware of what it is originally in the paper by Ian Goodfellow. Okay, so we're going to take those images and we're going to run them through the discriminator again. But this time we don't need any dog images, because the way that the generator learns is by trying to trick the discriminator. And based on whether it succeeds or not, it will update its weight. So it doesn't need to compare to any dogs or non-dogs. It just needs to try and trick the discriminator. And so the discriminator will provide an output. As you can see, the output is different to what it had before, because it has already been trained itself, and therefore it now knows what a dog, kind of more or less, it knows what a dog looks like, and it knows what a dog doesn't look like. And as you can see here, the numbers are not all like 0, 0, 0. They're kind of close to 0. They're lower, but they're not just all 0, 0, 0, because it takes time for the discriminator to learn as well. And this illustrates the concept that why these two should be trained at the same time. Because if you if, for instance, the discriminator was very well trained, like it had been trained for a very long time, or was trained separately and up until to a very good level, then and the generator was only being trained now, then the discriminator would always like completely leave no chances for the generator. And that's why it'll be too smart for the generator. The generator would have no chances of tricking the discriminator, but that would be not good for anybody. They have to train together. They have to kind of get better and better and better with time together. And so what we're going to do now is we're going to take these values and we're going to compare them to what it should have been. And do you know what these values should have been? Like what would you compare them to? Previously we compared them to a 0, but this time we're going to compare them to a 1, because now our objective is different. Previously we were training the discriminator, now we're training the generator, and for the generator it wants to trick the discriminator. It wants those values to be 1s, as it can see those values are much less than 1, so it will calculate the error, it will calculate the difference between each value and 1, and it'll take the aggregate error, and it will and that error will be backpropagated through the network of the generator this time around. And yeah, so that's going to allow the generator to now update its weights. There we go. So as you can see, it updated its weights there, and now next time round, it will know. It will do a better job. Do a better job at generating the images, because now it knows that this wasn't good enough. So it knows how the weights need to update it to improve that result. And again, this all boils down to neural networks and the process of backpropagation, and gradient descent and stochastic gradient descent, which happens in the neural network. So those are concepts that are required in order if you would like to understand in detail how this is happening, and those concepts we discuss in the annex. Okay, so that was the first step, right? So let's move on to step 2.